I just realized. And that's okay. So now that I'm not on mute anymore, what I just said was that we're gonna just jump right in today. Let me reshare this in case it's not showing up for anybody. So we're just gonna jump right into notes. We're not gonna have a warm up because we're getting a little too far behind where we should be. So just give someone in chat or unmute yourself. Just give me a thumbs up, a yes that y'all can hear me. I just always like to check. Yes. Okay. Cool. So we started 1-4 the other day. So that was about our cost, and we also got around to talking about revenue and profit. So we did skip this question right here, though, and so I want to start there. So just a reminder. So remember, our cost function's made up of two things, marginal and fixed, and right now we're just talking about linear functions because that's all we have. So in terms of a linear function, the marginal is the slope and the fixed is the y-intercept. So if we look at this example here, it says sketch a graph that would satisfy the designated situation. The first being that you have fixed costs are large, but marginal cost is small. So if we have fixed costs being large, that means we're going to have some large y-intercept. Not on the drawing. So our y-intercept is essentially large, but then the marginal cost being small, so we have a small slope. So that's almost like the graph we did yesterday last class time for the cost function, where essentially we start high up on the y-axis for our y-intercept being large. But then if we have a small slope, it means that we just, have a very not quite steep line going on. But that's kind of how that situation would look, is we would be starting high up on the y-axis and then just moving very slowly upwards as we move from left to right. Whereas when we jump over to the second one, it says no fixed cost, but marginal cost is high. Now, I want to be slightly careful with no fixed cost. We can say that because in the context of, having no fixed cost, it means that you don't have to pay anything up front. There still technically is a fixed cost. It would just be 0 in this case. So no fixed cost would imply a y-intercept of 0. So a fixed cost of 0. So there still technically is a fixed cost if you want to get technical. But we can because we're talking about money, it does make sense to say no fixed cost to mean 0. And then if marginal cost is high, that means we have a very high slope. So if we have a very large slope, then it's going to be a very steep line. So I just got to draw a relatively steep looking line. And again, these are sketches, so they've just got to get the point across. So those were just two little simple ideas that we wanted to look at. So moving on, now we've got to go back to that example that we started last time, but I said I wanted to come back to and we didn't finish it. Is there anyone who can't see my screen? Because I know a couple people have popped in after the fact, and Teams can be a little weird with that. As always, just let me know in chat if you specifically can't see my screen. I know most of you can, but anyway. But first, we need to pick up this definition that we missed last time as well. You can't? Okay. That probably just means that I need to unshare and reshare again. Is that better, Margaret? No? Oh, yeah, okay, good. All right, awesome. Yeah, Teams seem to be weird. If you come in after I already shared it, I have to reshare it. It's weird. Anyway, this definition that we missed last time. So the break-even point. For a company is where the profit is 0. So since we have that profit, now again, profit is represented by pi as just a symbol, not a number. So if I wanted to set profit equal to 0, I would just set that equation equal to 0, right? But I also want to note that, so a reminder, profit is equal to revenue minus cost. So if profit is 0, that would be the same thing as saying revenue minus cost equals 0. And if you add C to the other side, you get that revenue equals cost. So technically, when you're asked to find the break-even point, you kind of have two choices. You can either set profit equal to 0, or you can set revenue equal to cost. It's going to get you the same thing. So it's essentially, if you don't have the profit function yet, and you just have revenue and cost separately, it's probably just easier to set them equal to each other, because then you don't have to go through the extra step of finding profit. But if you have the profit function, might as well just set that equal to 0, or whichever one makes you happier at the end of the day, whatever floats your boat. Also note, the break-even point has two parts. It's going to have, I'm going to say break even, so BE for break even, quantity, because I'm lazy and will also run out of space, and the break even price. For the quantity, this is usually found via setting the profit equal to 0 or revenue equal to cost. I say usually because in very rare circumstances, that will actually give you the price, and I will try to explain that a bit better when we get down to this example in a second of how you tell the difference. And then the price is usually, so let me kind of split that up. So usually found by plugging the Q you just found into revenue or cost, not profit. And I'll also talk about that a bit more in a second. Now with Wiley, they kind of go back and forth on whether or not they want one piece or both pieces. And you usually just read the problem in the context, kind of fills in the information for you. So it'll either say the quantity of blah, in this case, you want the quantity. Sometimes it will then ask for the price, sometimes it won't. So just, make sure you're reading the problem to figure out what it's asking. If it's a question that I've written, so for a quiz or exam, I always want both parts, and I do try to put that in the instructions. I either bold point in break even point, or I then, instead of bolding it, sometimes I will literally say, make sure to state the quantity and price. But if it's a question that I've written, I always want both parts for the break-even point. So let's go back over this question here. Actually, let's just go ahead and do it from scratch. So let me just erase strategically before I scroll down too far what we did the other day, and we're just going to redo it because we only got through part 1 anyway. I'm going to talk about that at the end of class, Kayla. It semi-depends on how far we get, but I'm assuming we're just going to get through 1-4, so I'll talk about that. I'll talk about the homework at the end of class, because it's probably going to be that I need to figure something out. Well, I already have it figured out. But anyway, I'll talk about that at the end of class. So let's go through this example again. Consider the radio factory from the previous examples, the one we had started the other day, if they sell each radio for $15. So I reminded us, yes, I can't reshare my screen. There we go. You're welcome. So reminding us the cost equation from the previous example. Now we wanted to find the profit and revenue functions. Again, we technically did this yesterday. You know what I mean. But I just wanted to go through it one more time to remind us. So the revenue function, so remember that revenue, you always want to remember that that's price times quantity. That's like the big thing for remembering revenue. So then in this case, the price that they're selling them for is 15, so we get 15Q. And then our profit, so since we did go over this the other day, I'm going through it slightly fast, but of course, please stop me if you have a question. So profit is revenue minus cost. So our revenue function is 15Q. Our cost function is 7Q plus 24,000. Always put the cost in parentheses because you need to remember to distribute this negative when you simplify. So if we start simplifying that, we will get 15Q minus, whoops, getting ahead of myself, minus 7Q minus 24,000. So our profit function turned out to be 8Q minus 24,000. So we technically got that far the other day, so now let's continue forward. So the next thing we're asked to do is find the break-even point. So for the break-even point, again, you kind of have two options. You can either set the profit function equal to 0 or revenue equal to cost. Since we have our profit function here, I'm just going to go ahead and set the profit function equal to 0. But let me put over here, or 15Q equals. Just to remind you that literally, whichever one you do, you're going to get the same answer at the end of the day. So if we add 24,000 over to the other side, and divide by 8, you get Q equals 3,000. This is the break-even quantity. So, okay, so I said that I would talk about how do you know whether you just found the quantity or the price. Look at the variable. If you just solved for a Q, you found a quantity. If you just solved for P, you solved for a price. Now, 90% of the time, let me do something really quick. 90% of the time, you're going to solve for Q because it's going to be in terms of Q. Very few times you might have that revenue is presented, and cost in that case, is presented in terms of, you know, so whatever numbers I want, whatever. Sure, just that. Sometimes you'll have revenue presented in terms of price instead of quantity. It doesn't happen very often, but it does happen. So just kind of make sure you got to keep track of which variable you're talking about. 90% of the time, cost, revenue, and profit are in terms of Q, quantity, but sometimes they do turn out to be written in terms of price. And so if it's written like this, then R of P would be the Q value. So whatever R of P is would be the quantity, but the P value that you would be solving for is the price. Hopefully that makes sense. Again, 90% of the time, it's R of Q, pi of Q, C of Q. So we found our break-even quantity, but now we want to go ahead and find the break-even price. So we take this number that we just found, and as I wrote up here, so we're going to take that value that we just, value we just found and plug it into revenue or cost, not profit. Because if we plug it into profit, we're going to get 0. And while technically that is kind of the point, profit is 0, when you're asked for the break-even price, you want to know the non-zero price. Essentially, how much money did you have to get in for revenue and how much did you have to spend in cost, if you will, before you break even. That's kind of, you're looking for that non-zero value. Most of the time, I personally choose to plug it into revenue because that's usually the easier function. So I would go ahead and plug it into revenue. One thing I want to say really quick, this notation over here, most people recognize that that's function notation, but some people, it freaks them out for some reason. That's just saying that I'm plugging 3,000 into the revenue function. Like that, it's not R times 3,000. You can't manipulate that side of the equation at all. Sometimes I see people trying to divide by that 3,000 that's inside the R, and it makes me very sad, and don't do that. So just, if you're not aware, that's just function notation to literally just say, take this 3,000, plug it into the revenue function. Anyway, so we plug that into the revenue function, we get 45,000. So in this case, it would be dollars since it's a price. And this is our break-even price. Okay. So we would need both of these values for our break-even price, break-even point. Goodness. Hopefully that makes sense. I think one more person came in, so I gotta do this again. I'm salty at Teams, not salty at the people who are coming in. Anyway. All right, so, and now it's, where'd the number go? There we go. All right, so, well, now I gotta scroll back up so we can see the question. Part 3, sketch the revenue and cost functions and label the break-even point, and then I'll just read it because I'm going to scroll past it. And then after that, we want to sketch the profit function and label the break-even point. So, sketches. So I can make these, kind of rough. Don't have to worry about making them perfect. So in the first one, I'm asked to sketch cost and revenue. So we kind of did sketch cost on Wednesday, but so let's just sketch that again. So we have 24,000, so we're pretty high up on the y-axis, and then 7Q is a pretty small slope, so we're kind of going to just go up very slowly as we move from left to right. So this one, maybe I should have used a different color. Let me try to highlight it a little bit. This one is going to be our cost function. And then if I want to sketch our revenue function, well, our revenue function was just 15Q. So I have a y-intercept of 0 on that and a steeper slope. So again, these are sketches, so I'm not making it perfect. So all I need to do there is make sure it looks steeper than the cost function. Like I can kind of make it as steep as I want, as long as it's definitely steeper than the cost function. Hopefully that makes sense. Again, when you see the word sketch, it's just get the generic shape in there. So now that I've got the two equations mapped out, where does my break-even point show up? Where did I get the cost function from? That's technically from Wednesday, when we go all the way back to example 1. And we were told that they make the radios for $7 and they have $24,000 of fixed costs. So that's where we came up with the 7Q plus 24,000 that I just rewrote on the other one. So it's coming from this example that we started the other day. So our break-even point, well, if you think about kind of the two options you have, it's either profit is 0 or revenue equals cost. So in this case, since we have revenue and cost, it's going to be when they're equal, which is going to be when they intersect. So here is our break-even point. My V didn't draw. Even point. There we go. Okay, but then problem 4 asked me to sketch the profit function. So where's our profit function? Well, that's over here. So we got 8Q minus 24,000. So minus 24,000 as our y-intercept is going to be, somewhere decently below the x-axis. And then I've got 8Q as my slope, well, 8 as my slope. Now this is the only thing I'm drawing on here. So since, again, it's a sketch, we just want the basic shape. I can kind of make it as steep as I want because it's the only thing that's getting drawn on there. There's nothing to compare it to. So I can just go ahead and draw it however steep I want. Now the break-even point here, we got to go back to the other idea. Profit is 0. If profit is 0, that's where this is going to cross the x-axis. So this is where the break-even point shows up. Now I do want to stress one more time. I know technically if I'm considering the thing I just drew to be the break-even point, then some of you may want to say the break-even price is 0. But again, when we say break-even price, we want to know how much do we have to spend, how much do we need in revenue before that happens. So it's the break-even price is focusing more on how much you have to make or how much you have to spend before you get to profit being 0. So whenever we ask for break-even price, you always want to remember that it's either revenue or cost. You can only use those two when talking about the price piece of it. Questions on that? I'll wait a couple seconds in case someone's got to type in chat. Otherwise, we will move on. Is there a specific piece that you're confused about? Right, okay. back up to the definition. The break-even point is the place where maybe I shouldn't say place. The break-even point is when profit is 0. The quantity piece is slightly more important than the price piece. So when we really refer to break-even point, the main focus is how many items do you have to make or sell before you break even, before you have no profit. You're finally out of the red, but you haven't started making profit yet. How many things do you have to sell / make before you completely break even and can then start making profit? To find that, we can either literally set profit equal to 0, or since profit is revenue minus cost, we can kind of manipulate that to get revenue equals cost. So those are the two ways to find it. So either of those two options, profit equals 0, revenue equals cost, when you solve those, are going to give you a quantity value 95% of the time. That quantity value is going to tell you how many things you have to make / sell before you will have 0 profit. But technically, the break-even price has another piece associated with it, and that's the break-even price. So there's the break-even quantity and the break-even price. Again, the break-even quantity is a bit more of the focus when you're talking about it in context, but sometimes we do want to figure out what this break-even price is as well. Now, the break-even price is essentially, I want to know how much it's going to cost me, or how much I'm going to need to make in revenue for this to happen. So how much revenue am I making from selling that many items? How much is it costing me to make that many items to get profit being 0? So the break-even price, we need to specifically look at revenue or cost to figure out how much it's costing me, why we look at cost, or how much I have to make in revenue. And the reason it doesn't matter which one you look at is because of the fact that at the break-even point, revenue equals cost. So you get to pick whichever one you'd rather plug it into, because it's going to give you the same number. So the break-even point in general is important because it lets us know when we're finally out of the red and we're going to start making profit. When does profit equal 0? How many things do we have to sell before we can start making money? But when you break that down into pieces, it's made up of the two pieces, the break-even quantity and the break-even price. How many items is it, and how much is it costing me / how much revenue do I have to bring in before it will happen? Does that make more sense? Hooray! You're welcome. Any more questions? Okay. One note that's kind of getting drowned out at the bottom here. Note that so we've already talked about marginal cost, and that was technically presented on Wednesday. The marginal cost was the cost of making the next item. We also have marginal revenue and marginal profit as well. We can talk about marginal revenue and marginal profit. How much more money do I make from selling the next item? How much more profit? So they're both talking about how much, nope, don't say that. Marginal revenue, how much more revenue do I get if I sell an extra item? Marginal profit, how much more profit do I get from selling the next item? So it's still that idea of telling you how much more, essentially what's happening to that function if you increase the quantity by 1. How much more is it costing you? How much more revenue are you getting? How much more profit are you getting? But that's mainly just to say that marginal isn't just a word associated with cost. It can also be associated with revenue and profit as well. So, somewhat different idea. The supply curve. For a given item relates the quantity Q of an item that manufacturers are willing to make per unit time to the price P for which the item is sold. Now let me finish writing out the second definition, and then I'll try to say this in slightly more general English terms. Or maybe easier to understand English terms. Because that piece of willing to make per unit time per the price, that can get a little involved. But anyway, the demand curve relates the quantity Q of an item demanded by consumers per unit time to the price P of an item. The two kind of important bits here is, maybe I'm going to include that because I want to, that manufacturers are willing to make, and then demanded by consumers are kind of the two pieces that kind of help you figure out what these are saying. So the supply curve, so essentially, so imagine you're working at that radio factory and you decide that you no longer have the time to make the radios yourself. You want someone else to do it for you. So you go up to a manufacturing company and you say, hey guys, I want to sell radios for 15 bucks. And they're like, all right, if you're going to sell them for 15 bucks, we're going to make you 20,000 radios. And you're like, cool. Just kidding. I only want to sell them for $10. And then they're like, well, that's less worth our time. We're only going to make you 10,000 radios. So the supply curve is essentially saying, how many items is the manufacturer willing to make you for the price at which the item is going to be sold? Whereas the demand curve is you go out to the people and you say, hey guys, I'm going to sell radios and they're going to be $15. And people are like, great, then we're going to buy 30,000 radios. And you're like, awesome. Just kidding. I'm only going to sell them for $10. And then people are like, well, that's awesome. Then we'll buy 40,000 radios. So the demand curve is essentially saying how many of the item is going to be demanded by the consumers. How many are they going to buy relating to the price of the item? Hopefully that makes a little more sense. So let's look at this thing right here. Given the following supply and demand curves, what do P sub 0, P naught, P1, and Q1 represent? Now we do need to be slightly careful of which axis is which, and they kind of flip-flop depending on which problem you're looking at. Sometimes price is going to be the X, sometimes price is going to be the Y. But in this case, we have quantity being our horizontal value and price being our vertical value here. So if I want to look at P naught first, well, I don't have any numbers here. Obviously, I'm just thinking about these in terms of general terms. But so I have P naught being whatever value that is. But if I think about it, this point is going to have Q being equal to 0. Right? Because I didn't go anywhere in the Q axis. I just went straight up. So since that's technically a P-intercept, that would mean that Q is 0. So I have, no quantity here, right? So I have some price associated with a quantity of 0. And since this is our supply curve, this is going to tell us that this is essentially the price for which manufacturers are not willing to make any products. I went up to my manufacturing people and I said, hey, these radios are going to sell for $5. And they looked at me and they went, that's not worth my time, get out. So that's essentially giving me the price such that no things are being made for me. Whereas going over to our demand curve now, well, let me look at P sub 1. Well, again, this is technically a P-intercept, so this is going to tell us also that Q equals 0 here as well. But now we're in the context of demand, so it's kind of switching gears a little bit. So this is essentially telling us the price, whatever value this is. So the P sub 1 is telling us the price for which consumers will buy no products. And I'm sure you can phrase that better, but it at least gets the point across. You essentially go out to the people and you're like, yo, my radios are going to be $150. And everyone stares at you like you've gone crazy. And then you're like, then we're not going to buy it because that's too expensive. So it's essentially the price for which all of the consumers are going to be like, nah, we don't want it. And then if we look at our last piece of Q sub 1, now this one might sound a little weird at first, but it does technically make sense. Now this is a Q-intercept, so this is actually telling us that P is 0. Well, P is price, so that's telling us that the items that we're selling are being sold for $0. They're being essentially given away for free. And so this is going to be the quantity demanded. Here I'm using the word demanded instead of bought because buying something for $0 would sound more weird in my opinion. But anyway, quantity demanded when the product is free. Now in your mind, you might say, well, if it's free, wouldn't everyone want one? Well, not necessarily. You know, I could go out and say, hey, I'm giving away radios. And some people would be like, sweet, free radio. And then other people would be like, I don't really need a radio. So it does make sense for there to actually be a value for that. Even if the product is free, there probably is going to be a cap on how many you're still going to be able to quote unquote sell. Questions on that? Okay. Seems like we're good. So this next one is a somewhat common type of problem. And not only in this section, these types of problems can come up in other sections as well, I believe, as long as I'm remembering correctly. But anyway, so we have a movie theater sells 50 tickets a week when the price is $10 per ticket and sells 75 tickets when the price is $8 per ticket. Find the demand function, assuming it is linear, as a function of price. Find the revenue function for the theater. So assuming it's linear, well, that's good because that's the only type of function we have to work with right now. And we have that demand as a function of price, or demand is a function of price. So that means that now here, whenever we're talking about supply and demand, you could use D and S for demand and supply, but we're usually still talking about quantities and prices, so we'll still usually use Q and P. So we're going to have Q equals F of P here, where this is our demand. So demand as a function of price. Can I write the, why is my pen not working? Demand, thank you. So if demand is a function of price, D equals F of P, but again, we're usually going to be using Q's and P's here. So now that I know kind of what order I need to work with, now I can take those two pieces of information that I'm told in the very beginning, yeah, so that's essentially what I'm saying, is that the demand is representing the quantity of things. So that's why I'm using Q. And it's common to kind of use Q instead of D for demand. But again, whatever floats your boat, if you'd rather use D, go right ahead. Though I will say, because I know what the second half of the question is going to need, it's better to use Q. So I'm going to use Q. But yes, what you're saying is perfectly correct. The quantity here is representing the quantity that's demanded. Anyway, I'm rambling about the same thing multiple times. So now that we know essentially the order that it goes in, we can take these two pieces of information, this $50 a ticket, 50 tickets at $10 and 75 tickets at $8, and kind of turn them into the points that we're going to use to write the equation of our line. So since our points would be P comma Q's, the 2 points we're working with is a price of $10 for a quantity of 50 tickets and a price of $8 for a quantity of 75 tickets. And now that I have those two in their correct order, I can now go about finding the linear equation. So the first step in finding a linear equation always is always to find your slope. So we've got to find our slope first. So personal preference, I always put the larger y value first, whatever floats your boat. And then, so if I put the 75 first, the 8 must come first. So we have 25 over -2. So -12.5 for our slope. Once we find our slope, we choose a point and then we plug it into, I'm going to write down y equals mx plus b, but then in our case, it would turn into q equals mp plus b. I can't remember if I've said this to this class specifically or not. If it helps you to work in terms of y and x, you can do that. The only thing you need to be careful of is whenever you write your final answer, it should be in terms of the variables of the problem. So if you wanted to use y and x while you're doing all the work for it, that's perfectly fine. But you then will have to change over to q and p to write your final answer. Especially for Wiley. Wiley is very picky when it comes to variable names. If you put in the wrong variable, even if the rest of it is perfectly correct, it'll mark it incorrect. So specifically in Wiley, also for things that I write, I don't necessarily count it as completely wrong like Wiley, but I will take a point, maybe a half a point off if your variables are not the right ones. So if it helps you to work in terms of y and x, perfectly fine, but make sure you switch over at the end. Anyway, which one of these points makes me happier? I'm going to choose 10 and 50 because, I don't know, I like those two numbers better. So the q value is 50 that I chose. M is -12.5. P is 10 plus B. So we get 50 equals -125. That 2 looks silly. Plus B. Add 125 to both sides. Yeah, 175 equals B. Always remember that you then have to actually write the actual equation out. So we have Q equals 10. No, my notes are wrong. 12.5 P plus 175. So that would be our demand function, but we still aren't done the question because it also then asked us find the revenue function for the theater. And so what we're going to do then is, so remember that revenue, gotta be careful. I'll explain why in a second. No, erase, please. Thank you. I'm just going to put R without the of. And so remember, revenue equals price times quantity. It should be positive because what we're going to do here, if we go back here really quick, we wanted to add the 125 to both sides. So 50 plus 125 would give us positive 175 equals B. Does that make sense? Okay. So revenue equals price times quantity. When I said you were going to want to remember that, I meant it. So here's a very kind of common thing that's going to happen here, especially when it comes to demand and supply equations. We have a Q right here, and we have a Q right here. So essentially what we're going to do is we're going to replace the Q and the revenue kind of formulation with the demand function that we just found. So that would make our revenue function equal to P times -12.5 P plus 175. We're taking that entire, quote unquote Q value and plugging it in with the equation that we just found was equal to Q. And that's why I stopped myself from writing R of Q, because now our revenue function is technically in terms of P, so it would be R of P. And technically we should distribute this P to get -12.5 P squared plus 175 P. And then this would be our revenue function. Questions, concerns? Sorry. One second. All right. Last bit here is the equilibrium point. The equilibrium point is where supply and demand are equal. It's very similar to the break-even point. It's just that now it's in terms of supply and demand instead of profit, revenue, and cost. And this is also made up of the equilibrium price and equilibrium quantity. So again, just like with the break-even point, it's got kind of two pieces to it instead of just one. So say we wanted to find the equilibrium point if our demand equation is 100 minus 2p and our supply equation is 3p minus 50. Well, if it's where supply and demand are equal, you're just going to take those two equations and slap them equal to each other. 100 minus 2p equals 3p minus 50. I always like to collect the variables on the same side first, and I always like my variables to be positive if I can, so that's why I would take it that way personally, but however you want to algebraically solve that is fine. I would then add 50 to both sides. Divide both sides by 5. Get p is 30. But again, with the equilibrium point, especially for questions that I gave you, I always want both. So we have the price, but now we need the quantity. Now again, demand and supply are quantities. So the quantity demanded and quantity supplied. So those two are Q values. So since these two equations are equal, I get to pick whichever one I want to plug in P for and just get my quantity value. So I prefer this one just because the 100 minus 2p, because I just do. So 100 minus 2 times 30, I take that value I just found and I plug it in. So 100 minus 60, so 40. And just for the sake of being clear, that would mean that our equilibrium point is at $30 and 40 items. If you said 40 items, $30 in the opposite order, that's perfectly fine as well. 7. Questions, concerns about anything we went over today? Before I start babbling about homework and also Monday, because Monday's weird. If you didn't know, Monday's weird. All right, so obviously we didn't get to 1.5 and I really wanted to get to 1.5. But so 1.5 is on your homework, but obviously we haven't talked about it yet. And as I've mentioned before, I try to have everything done by Friday. And unlike last time, we haven't been able to talk about it at all, 1.5. So I don't want to, force you to do all of 1.5 Monday. So what's going to happen is, so I can't take off problems on Wiley after it's been assigned, which is what I was going to try to do, but I found out that that's not possible. So essentially what's going to happen, and I will send out, a Blackboard announcement / email about this so that people hopefully remember. So I don't remember off the top of my head, but essentially what's going to happen is I'm only going to grade the second homework out of however many points the 1.4 stuff add up to. So say the homework was out of 96 points, but only 50 of them were from 1.4, then the homework's going to be counted only out of 150, which means you do not need to do any of the 1.5 problems this week. the 1-5 problems will be on the next homework, so they will still exist. But you don't have to do them on this week's homework because we haven't talked about it yet. So while your score in Wiley will look quote unquote bad, the score that I'm going to take and put into Blackboard and in the actual official grade calculation will only be out of the stuff that's on 1-4. You should be able to tell which ones are in 1-5 when you're in the thing. I believe. Let me pull it up really super quick. I believe when you're in it, as long as it's not only for my instructor view, on the side when it gives you like the list of questions, it should say like chapter 1 section 1.4 or just say 1.4 or something like that. It does tell you that. Cool. So yeah, if you have the questions up on the side, there should be a bar that kind of says, you know, and it should have 1.4. It should say something like 1.4.005, 1.4. Whatever. Can I still post the 1.5 notes? I mean, in general, I could, but since we're gonna go over them on Monday and then you're gonna have the homework next week anyway, I don't really see the point. So I'm gonna go with no. Because seriously, don't do any of the 1.5 on this one because you're just gonna have to do it on next week's homework. So don't do it. Sorry, I got to start. Monday. So that's the homework. So I will send out a thing on Blackboard that says only do 1-4. If you've already done 1-5, just keep it in your brain and it'll be super easy next week. Monday, I believe it's this Monday, is an asynchronous day. Because, you know, on a usual schedule, we would have, sorry, everything's freaking out. On a usual schedule, we wouldn't meet because it's Labor Day. But since they moved the schedule around to have everything done by Thanksgiving, it's an asynchronous day. What that means is that I'm going to be posting videos for you guys to watch on your own time. I will be sending out information on this as well. I need to figure out if I can do this or if the university would get mad at me. I'm thinking about coming to class time anyway and having it be completely optional for you to come by if you want me to go through the stuff like live and you don't want to just have to watch it on your own time. I'm going to try to see if that's going to be okay, and the university is not going to get mad at me if I do. But technically, we don't meet, quote unquote, on Monday. And the material that you'll need to cover will be on a video on Blackboard that you would watch on your own time. So once again, I'll send out the information about the homework, and then I will send out information about Monday on Blackboard as well, so that it's just all there and you can refer back to it later. If you have questions, stick around about content or anything I just rambled about. Otherwise, have a good day, have a good weekend. See you around. Remember, SI sessions. He just posted something in chat. Oh, I can stop the recording now.